Alright guys, we are going to start our last lesson for Math 95, and what we're going to be dealing with is we're going to be graphing quadratic functions. Okay, so the standard form for a quadratic equation is ax squared plus bx plus c equals 0. So this is what we've been working with for the entire semester. When it equals 0, that means that we're going to have to solve. When you do the standard form for a quadratic function, the only thing that changes is you have ax squared plus bx plus c equals y, or you might see it as f of x. And you'll see that in college algebra when you take it next quarter. So the graph of a quadratic function looks like this. You can have this type of U shape, a U shape, or an N shape. Okay, and what these shapes are called mathematically is they're called a parabola. So P-R-A-B-O-L-A. So mathematically we call these parabolas. If it's a U shape, that means my A is positive. If it's an N shape, that means my A is negative. Okay, so that's one way that you can check yourself while you're working through these kinds of problems. So, the axis of symmetry is the lowest or the highest point on the parabola is called the vertex. Every parabola or every quadratic that you graph is going to have a lowest point or a highest point, and it's going to be called the vertex. So it's going to be some point x, y. So if we look at this parabola, the first thing that we notice is that it's U-shaped, so our A is going to equal 1, and our lowest point right here is going to be at 2, 0. Now the next thing that we have is a vertical line. A vertical line through the axis is called the axis of symmetry. So we usually put that vertical line as a dash line because what it does is it literally creates a mirror image. If we were to cover this up and have a mirror, then what we would be able to see is we would be able to see the other side of that parabola. So what I want you to think of for your axis of symmetry is that it goes through the vertex, and then it's going to be a mirror image on the left and the right side. Which is going to be super important when we start graphing these. Now, in order to start graphing quadratic functions, what we need to do is we need certain points. The first point that we need is your vertex, so that's going to be some type of x and some type of y. And it's either going to be your lowest or your highest point, depending if it's a U-shape or an N-shaped parabola. Alright, then we need our y-intercept, and remember your y-intercept is where your graph crosses your y-axis. Okay, that's going to be 1 point, so we're going to let our x equal 0, and then we're going to solve for our y. And then we're going to find our x-intercept, and our x-intercept is where our parabola will cross our x-axis. So instead we're going to let y equal 0, so we'll have some type of number 0, then some type of number 0. And this is what we've been doing all chapter. So we can either use factoring, like in 6.5, we can use the square root property, we can use the completing the square, or we can use the quadratic formula. Okay, so this is 6.5, 9.1, 9.2, and 9.3. Alright, so we'll definitely get some practice with that, but you should feel pretty familiar with it. Okay, so now let's look at our steps. So the steps to graph a quadratic function, the first thing that you have to do is you have to identify your ABCs, so just like we did when we were trying to find the quadratic formula. The next thing that we have to do is we have to find the vertex. Remember, a vertex is going to be some x and then some y point. So to find our x, and I do want you to write this formula, you need to go x equals negative b over 2a. Then you're going to solve for it by plugging and chugging, and you'll get some type of x value. Now, in order to get your y value, what you have to do is you have to plug in your x, and then it will solve for the y, which I'll show you what that means in a minute. Step 3, we're going to find our y-intercept. So when we find our y-intercept, we're going to let x equal 0 and solve for y. So again, it's going to be some type of 0 and a point. Then we're going to find our x-intercept. So we're going to let y equal 0, and most of the time you're going to have 2 points. So it'll be something like this. And again, you're going to use 6.5, 9.1, 9.2, 9.3, or you're going to factor. The last step is you graph all found points. You're going to draw your axis of symmetry. So I need that vertical line as a dash, and then you're going to connect dots. So there are times where you're going to have to find another point, and we have a couple of examples that are like that. So we'll have to let x equal some type of number, and then we'll solve, which I'll show you what that means in just a few moments as well. Alright, so let's do it. So the first quadratic function that we have is y equals x squared minus 2x minus 3. So the first step that we have to do is we have to find our ABCs. So A, B, C equals, so my A is going to be 1, my B is going to be negative 2, and my C is going to be negative 3. Now the first thing that I notice when I look at my A is my A is going to be positive. So that's going to tell me that I'm going to have a U-shaped parabola. Okay, so that's step 1, identifying your ABCs. Step 2, we have to find the vertex. So first thing I need you to do is I need you to write your formula. So you got x equals negative b over 2a, and once you write your formula, then it's a simple plug and chug. So we got negative 2, I'm sorry, how do I, okay. So we got negative 2 over 2 times 1, which will clean up to be 2 over 2, and 2 over 2 gives me 1. So my x is going to equal 1, and now all I got to do is find my y. So to find my y, I plug it back into the original equation. Wherever I see x, I'm going to plug in a 1. So I'd go 1 squared minus 2 times 1 minus 3. And we know that 1 squared is 1, minus 2 minus 3. And 1 minus 2 minus 3 will give us negative 4. So therefore my vertex point is going to be 1, negative 4. Okay, so the next thing that I have to find is I have to find my y-intercept. So I'm going to let x equal 0, and I'm just going to plug and chug. So I would go 0 squared minus 2 times 0 minus 3. 0 squared is 0, minus 0 minus 3, and y will equal negative 3. Now the cool thing about this, when you're trying to find your y-intercept, it's always going to equal out to whatever your c is. So that's one way that you can check yourself. So we've got our point 0, negative 3. And then the next step that I have to do is I have to find my x-intercept. So we're going to let y equal 0. And when I let y equal 0, I've got x squared minus 2x minus 3. Alright, I see that I have 1, 2, 3 terms. So if I'm going to factor this, it could either be an a equals 1, a doesn't equal 1, or a perfect square trinomial. I definitely see an a equaling 1 for this, which right up here I could check that as well. So if I'm going to factor this using 6.5, I set up my parentheses. I go x, it's minus, minus. So it's going to be plus, minus. I find my factors of 3, which the only factors of 3 are 1 and 3 because it's prime. So the important part is my sign step. So I have to use subtraction because it's plus minus to get to negative 2. So in order to get to negative 2, I'd go 1 minus 3, because 1 minus 3 will give me negative 2. So that means my 1 is positive, my 3 is going to be negative, and I'm almost done. I gotta go 0 equals x plus 1, 0 equals x minus 3, and then I gotta solve it. Minus 1, so negative 1 equals x, plus 3 plus 3. 3 equals x. So I've got a point -1, 0, and I've got a point 3, 0. So right now I've got 1, 2, 3, 4 points that I can graph, which is awesome, and it will make my parabola so easy to see. Okay, so I'm going to label my axes. Here's my x, here's my y. I start at my origin 0, 0, and I've got to get to my vertex. So I'm going to go to the right one, and then I'm going to go down 4. 1, 2, 3, 4. This will be my vertex. Through my vertex, I have to draw my axis of symmetry. So I'm going to go ahead and put those vertical lines as well. Okay, now I'm going to graph my y-intercept. So I start at 0, 0, and I've got to go to 0, -3, which is about right here because I go down 3. And then I go back to my origin, and I'm going to graph my x-intercept points. So that will be -1, 0, which is right here, and then 3, 0. So to the right, 1, 2, 3, 0. So if I go on my left side of my parabola, it looks something like this. Now on the right side of my parabola, yes, we can totally draw it, but to make it look more neat, what we can do is we can draw this additional point, because remember, your axis of symmetry is going to be like a mirror image. So because this is 1 unit to the left, that means it's going to be 1 unit to the right as well. And we can mathematically find it. We will later, but you don't have to if you have already a point there. And then we draw our parabola. And that is how you graph a quadratic function. Alright, let's try another one. So we have y equals x squared plus 4x plus 4. Alright, step 1, find our ABCs. So if I look at my A, it's going to be 1. My B is going to be 4. And my C is going to be 4. Now again, since my A is positive, that means I'm going to have a U-shaped parabola. So when I'm graphing it, I kind of can see where it's going to go. Okay, so now next thing I have to do is find my vertex. So I plug it into my formula, x equals -b over 2a. And I go -4 over 2 times 1, which would be -4 over 2, which would clean up to be -2. Now, you've got to be super careful whenever you get an x as a negative value. You've got to make sure and keep it in parentheses so it will clean up really nice. Alright, so we go y equals -2 parentheses squared plus 4 times -2 plus 4. -2 squared is going to be 4 minus 8 plus 4, which will give us, what, -4 plus 4, so that's going to be 0. So my vertex point is going to be -2, 0. Okay, next thing that I've got to do is I've got to find my y-intercept. So in order to find my y-intercept, I'm going to let x equal 0. So I've got y equals 0 squared plus 4 times 0 plus 4. Give me a second to copy that down. Okay, so then I'm going to clean that up. 0 squared is 0 plus 0 plus 4. So y equals 4. So again, to check myself, my y-intercept is always going to be whatever my c is, written as a point. So I've got 0, 4. So now I've got 2 points to graph. Now what we've got to do is we've got to find our x-intercept. To find our x-intercept, we have to let y equal 0. And if I let y equal 0, then I've got 0 equals x squared plus 4x plus 4. Alright, so again, I've got 1, 2, 3 terms. If I choose to do it by factoring, I could either do a equals 1, a equals 2. I'm sorry. A equals 1, a doesn't equal 1, or it could be a perfect square trinomial. That way definitely works. Another way that I can look at it is I could do a completing the square. So I think this one I'm going to approach with a perfect square trinomial just so we can have the practice of it. So I take the square root of x squared, which is x, the square root of 4, which is 2, and remember we have to check it. So we go 2 times x times 2. This 2 just means that we're dealing with an even digit. So we get 4x if we multiply that out, which this matches this, so we're good to go. So we would go 0 equals a binomial squared, and we would plug in x plus 2. Now with this, if we're looking at it, we still have to solve it. So we only have to write it one time because we would be writing the exact same thing twice. So you really only need to write it one time. And when we solve it, we're going to subtract 2 on both sides, and we get negative 2 equals x. So this third additional point that we have is negative 2, 0. Now the problem with that is it matches our vertex point. So what that means is that we're definitely going to have to find an additional point, because technically we're only graphing 2 points. So let's do this. So if I look at this, here is my x-axis, here's my y-axis. I start at 0, 0, and I got to get to my vertex, so I go to the left 2, and here's my vertex point. So I'm going to draw my vertical line. Then what I'm going to do is I am going to graph my y-intercept, which is at 0, 4. So I start at my origin, I go up 1, 2, 3, 4, and here is the right side of my parabola. Now, we have no clue what's on this side. So what that means is we're going to have to let x equal some type of number, and then we're going to have to solve for it. The way that you know what to let x equal is you look at your distance from the point that you just drew in your axis of symmetry, because it has to be a symmetric. It has to be the same on both sides. We call that equal distant. Alright, so what we see is we have 2 units down. So what we're going to do is we're going to take where my pen is and where my finger is, and I'm going to go back down to the x-axis. Okay, so I know I'm going 2 units to the right from my vertex point or my axis of symmetry. So in order for it to be symmetric, I have to go 2 units to the left. So I'm going to let x equal 1, 2, 3, 1, 2, 3, 4. I'm going to let x equal negative 4. Again, please be careful of your parentheses. So I got y equals negative 4 squared plus 4 times negative 4 plus 4. So negative 4 squared is going to be 16. Positive times a negative is a negative 16 plus 4. So 16 minus 16 gives us 0, plus 4 gives us 4. So the point that I just found was negative 4, 4. So I go to my origin, I go to the left 1, 2, 3, 4, and then I go up 1, 2, 3, 4. Now, I know, and I always get asked this question, well, if we just see it, can we graph it? No, I need to see this math because I need you to know what you know what you know. So please make sure that you find out what that additional point is going to be. Okay? So, let's look at the next one. We got y equals negative x squared minus 2x minus 3. First thing I do, find my ABCs. My A is going to be negative 1, my B is going to be negative 2, and my C is going to be negative 3. Okay? So what I notice is my A is not positive this time, so my parabola is going to definitely be an N shape. Okay? So the next thing that I've got to do is I've got to find that vertex. I'm going to write down my formula. X equals negative b over 2a, and then I can just plug and chug. So I got negative 2 over 2 times negative 1, and we know a negative times a negative is a positive, so that's going to be positive 2 over negative 2, which will clean up to be negative 1. Again, remember your x is negative, so please, please, please watch your parentheses. So we've got y equals negative negative 1 squared minus 2 times negative 1 minus 3. Alright, now when we approach this problem, you got to remember PEMDAS. Remember the please excuse my dear Aunt Sally. Okay, so we got to deal with exponents before we deal with multiplication. The common mistake that I see is people try to multiply this and then square it, but what you have to do is you have to take this negative 1 squared. And negative 1 squared is going to be positive 1. So we've got positive 1 times a negative 1. So my answer is going to be negative 1. Then we have a negative 2 times negative 1. So that's going to be plus 2 minus 3. And when I go negative 1 plus 2 minus 3, what I'm going to end up getting is negative 2. So my vertex point is going to be negative 1, negative 2. Alright, next thing that we're going to find is we are going to find our y-intercept. So we're going to let x equal 0. So we got y equals negative 0 squared minus 2 times 0 minus 3. 0 squared is just 0, doesn't need to be positive nor negative. 2 times 0, 0. And then negative 3, so y equals negative 3. Again, your y-intercept is really going to be using your c value, so you've got 0, negative 3. Okay, step 4 is we have to find our x-intercept, so we're going to let y equal 0. So I get 0 equals negative x squared minus 2x minus 3. Now if I look at this, since my a does not equal 1, and that's actually a negative 1, the only option that I have is my quadratic formula. So I'm going to go x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then after I write my formula, I can plug and chug. So I've got negative 2 plus or minus the square root of negative 2 parentheses squared minus 4 times negative 1 times negative 3 all over 2 times negative 1. Okay, so if I clean this up, that's going to be 2 plus or minus the square root of 4. Negative 4 times negative 1 is going to be a positive 4. Positive 4 times negative 3 is going to be negative 12 over negative 2. Alright, so if I continue to clean this up, then I've got 2 plus or minus the square root of negative 8, because 4 minus 12 gives me negative 8 over negative 2. But like we talked about in 9.3, are we ever allowed to have a negative underneath the square root? Nope. So what we have to do is we have to pull that out. So we'll have 2 plus or minus I square root 8 over negative 2. Now you can stop right here, because what this means is it's going to be an imaginary number, meaning it's never going to cross our x-axis, which is okay. That happens. I'll show you what to do in just a moment. Okay, so let's graph what we know. Here's my x, here's my y. I start at my origin and I go to the left, and then I go down 2. And this is going to be my vertex point of negative 1, negative 2. I'm going to draw my vertical line through that. Okay, the next point that I have, so I'm going to box this. The next point that I have is 0, negative 3. So I start at my origin and I go down 1, 2, 3. So this time I only have the right side of my parabola. So again, I'm going to have to let x equal some number. Alright, so how we do this is we take our axis of symmetry and we take the point that we just drew and we go back to the x-axis. So we know that we are going to be 1 unit to the right, so since it has to be symmetric, we have to go 1 unit to the left. So we are going to let x equal negative 2. Please make sure you watch your parentheses, because that's going to be super important as well. So we've got y equals negative 2 squared minus 2 times negative 2 minus 3. So you're going to have y equals, remember, please excuse my dear Aunt Sally, I've got to deal with my exponents first, so negative 2 squared is going to be 4. So I'm going to have negative 4 plus 4 minus 3. Negative 4 plus 4 is going to be 0, and then minus 3 is going to just leave me with negative 3. So the point that I just found was negative 2, negative 3. Go back to my origin, go negative 2, go to the left 2, go down 1, 2, 3, and there's my point. Do I need to see this math? Absolutely. Alright, so we are going to have one more problem that I want you to work, but I'm going to change it up just ever so slightly. So please, before you start going at it, make a quick correction for me. Instead of this 4, I want you to make it a 6, and instead of it being positive 2, I want you to make it negative 5. So pause the video for a second and work this problem, please. Okay, so if I approach this, I'm going to let my A, B, C's, because that's my first step. My A is going to equal negative 1, my B is going to be 6, and my C is going to be negative 5. Now again, since my A is negative, that means I'm going to have an N-shaped parabola, which is A-OK. So step 2, we have to find our vertex. In order to find our vertex, we go x equals negative b over 2a. Please make sure that you write your formula every time you do it, because I want to make sure that you got it down. So then we're going to plug it in. We're going to go negative 6 over 2 times negative 1. So that will be negative 6 over negative 2. And we know a negative over a negative gives us a positive. Okay? So we're going to let our x equal 3. Now we got to figure out what that y is going to be. Make sure that you keep this x in parentheses. So I've got negative in parentheses 3 squared plus 6 times 3 minus 5. Okay? Do not include this negative with the 3 or it will mess up your problem. Okay? So 3 squared is 9. 9 times negative 1 is going to be negative 9 plus 18 minus 5. And negative 9 plus 18 is going to be positive 9 minus 5 will give me 4. So my vertex here is going to be 3, 4. Alright, next step that I have to do is I have to find my y-intercept. So I'm going to let x equal 0. When I let x equal 0, I've got y equals negative 0 squared plus 6 times 0 minus 5. So if I clean that up, I've got y equals 0 plus 0 minus 5. Therefore, y equals negative 5. So my y-intercept is going to be 0, negative 5. Alright, now I've got to find my my x-intercept, so I'm going to let y equal 0. And when I let y equal 0, I've got 0 equals negative x squared plus 6x minus 5. Now again, if we look at this, we are going to have to use the quadratic formula. Do I want you to write the formula? Yes, absolutely. So we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I plug and chug, I got negative 6 plus or minus the square root of 6 squared minus 4 times negative 1 times negative 5 all over 2 times negative 1. I'm going to slide it over just a little bit. So I've got negative 6 plus or minus the square root of 36. Negative 4 times negative 1 is going to be a positive 4. Positive 4 times negative 5 is going to be negative 20 over negative 2. Okay? So now let's continue to clean this up. So we got x equals negative 6 plus or minus the square root. 36 minus 20 is going to be 16 over negative 2, which will be negative 6 plus or minus 4, because 16 is a perfect square, over negative 2. Now, we can use our triangle canceling, which we've been using since chapter 8, and we know that 2 can go into 6, 4, and 2. So we're going to use the negative 2. So that's going to be negative 6 over negative 2, which would be positive 3, plus or minus 4 divided by negative 2 is going to be plus or minus 2, because we're going to cover both the positive and the negative. So we have x equals 3 plus 2, which is 5. So one of our points are going to be 5, 0. And then we got x equals 3 minus 2, which is going to be 1. So 1, 0. So again, woohoo, we got 4 points. So this one shouldn't be too bad. Hopefully you did well on it. Alright, so last thing we got to do is we got to graph it. So here's my x, here's my y. We're going to start off by graphing our vertex. So I go to my origin, I go to the right 3, 1, 2, 3. I go up 4, 1, 2, 3, 4. I draw my point. I make my vertical line, which is my axis of symmetry. I go back to my origin and I'm going to try to find my y-intercept, which is at 0, negative 5. So I go down 1, 2, 3, 4, 5. Then I'm going to go to my x-intercept. So go back to my origin and I'm going to do 5, 0. So I'm going to go to the right 1, 2, 3, 4, 5. Draw my point. And then I'm going to draw my other point at 0, 0, 1. So origin, I'm going to go to the right 1. So this time the left side is going to be nice and pretty. And then the right side, we're just going to have to do a little bit of work. So because I already have this point, I don't have to find it mathematically. I can just look at their graph and do it. I've got 1, 2, 3 units on the left, so I need to go 1, 2, 3 units on the right to draw that other parabola to make it look nice and pretty. And guys, I know this takes a lot of work, but I guarantee you can do it with a little bit of practice. So what I need for you to do now is I need you to go and do your homework and get this knocked out for me, please. And hopefully this helps.